Welcome to the SPE podcast, powered by the Society of Petroleum Engineers. You're listening to SPE Live, direct lithium extraction from produced water in Brine well. The audio from this episode was previously recorded on December 4th, 2024.
Welcome to SPE Live. Today's conversation will focus on direct lithium extraction from produced water and brine. I'm Elena Melkert, president of Energia Consulting, LLC, the host of Oil and Gas Upstream podcast, and a proud member of Society of Petroleum Engineers. I'll be talking with Marshall Carolus, a subject matter expert on today's topic. Today's SPE Live will last 30 minutes. We encourage you to ask questions in the chat during the program. It's now my pleasure to introduce our guest. Marshall Carolus is a vice president with Intech Incorporated, an energy management consulting firm headquartered in Arlington, Virginia. He has nearly 20 years of experience modeling natural resources such as oil, gas, and other mineral resources, modeling petroleum, logistics and infrastructure, and market assessment. Mr. Carolus is currently leading Intech's modeling efforts related to direct lithium extraction, DLE, and the extraction and refining of other critical minerals. Also, Marshall is the author of numerous presentations and reports on energy economics and resource assessment, and is a longtime member of Society of Petroleum Engineers. Marshall, welcome to SPE Live.
Thank you, Elena. It's a pleasure to be here.
Great. Well, we're so glad that you're here, and we have a few questions for you to sort of guide the conversation. I hope that you will be sharing with us your subject matter expertise in this area.
Sure.
So our first interest in direct lithium extraction is related to the technologies and how they differ from conventional lithium extraction.
Okay, and before we get to that, let me preface this, that where we're coming from is that Intech, we work in the petroleum engineering field, and so we're building upon our basis with that. All of our understanding of DLE is coming from petroleum engineering sector. Now, and that engineering knowledge lets us talk about the differences between the DLE and the conventional production. And right now, there are two other ways that lithium is being produced right now, either through a mining approach, working with spodumene or other hard rock materials, or a brine extraction and then solarization. So you're evaporating the lithium before you are concentrating it and producing it. So those are the two active lithium extraction processes. And then we've got DLE, which is taking the lithium straight from the brine and doing it in using some new technologies and approaches. And so that's what we'll be talking about today, Elena.
Great, Marshall. Thank you. Thank you so much for launching us in that way. So what is the U.S. endowment for lithium naturally occurring, and where is it located geographically?
Okay, so lithium is found in the United States in many different areas. And let's start with the hard rock materials, and those are looking mostly in the western part of the United States, California and Nevada. And then there is the target for the direct lithium extraction, which will be the brines and the produced produced water from oil and gas production. And those are dispersed geographically all over the nation. So you've got production potential down in Smackover in Arkansas and Texas, Louisiana, which I'm sure you've heard about in the news. You've got potential in the Permian Basin and in Oklahoma. You've got it up in the Bakken and then over into the Appalachian and the Entrance Shale. So the lithium from the brines, it's a very diverse resource base. And just to give you a sense of how much what we've found for that, we're looking at about 2,300 potential prospects for it, where you can actually do some sort of direct lithium extraction.
Okay, and again, with respect to the lithium, is it in the rock? Is it in the fluids? How do we, just do that little piece for us again?
Okay, so Lithium is found in two main structures. You've got the hard rock, which is found in clays or other minerals. That's the spodumene. That's the mining side. Then you've also got it in the produced waters and in the brines. In that case, it's another salt within those waters, within those brines, and that is the oil field production. That's the gas field production, produced water, or also the water coming in from underneath those reservoirs from the aquifers. So it's both in the water, which is where you can get it through the DLE technologies, or it's also in the rocks and in the minerals where you would need to get that through either an in situ mining process or through conventional underground or surface mining and extraction. So it's in both the brines and it's in the minerals themselves.
So is it fair to ask you, is it more prolific in the produced water, or will we find higher concentrations of lithium in in just brines and aquifers? And how would we compare that?
Yeah, that's a really good question. And you are seeing concentrations for the produced waters of now up to, and they measure this in terms of parts per million or percentage weight, up to 14 or 1,700 parts per million in the brine. Now, and then that compares with some of the rock resources where you're getting into the 1,500, 2,000 parts per million for the conventional mining too. So you're looking at a comparable concentration, but you're getting it into a form that is easier to work with the technologies. And so you can go straight for the lithium through the DLE instead of going through a mining approach for the spodumene or for the other mineral bases. So that's the real difference in terms of the resource quality. It's going to be the accessibility and the ease of work with the materials.
Excellent. And so these technologies for the lithium extraction from the brines, give us a sense of the workflow. I mean, obviously, our target, the prize, is to get the lithium that we need for batteries.
Right.
But it comes out probably from the extraction process in a different form. So help us appreciate that.
Sure. Now, this is going to be talking about the DLE, obviously.
Yes.
And the process goes like this, that you are starting off with the brine or fluid down in the reservoir in the aquifer, and you're producing that either along with your oil and gas production or through dedicated wells. So you bring the brine to the surface, and then you do some concentration and cleaning to get it ready for the DLE technologies. And those technologies, and there are several of them, several different approaches, are used to extract the lithium and to clean up and remove some of the impurities and associated chemicals, the magnesiums, the calciums, other elements that you need to remove at that point. And then once you've gotten to a lithium stream, that's precipitated using a sodium carbonate. That gets you to the lithium carbonate, which is then dried and cleaned and packaged and sent off for using in the battery situations.
And these technologies, where do we find them? Are they existing technologies? Is that our area of research? Is there a frontier there? Give us a sense of the technology piece.
Sure. Okay, and some of these are in place right now because you're using, let's back up a second. There are 5 general branches for technologies. You've got your membranes, you've got your ion exchange, you got your absorption, and then you've got some chemical and electrochemical approaches. And some of these are right now in process for removing impurities from some of the projects. For example, you're looking at the absorption technologies to remove the impurities from the concentrated lithium brine in the solar evaporation pond. But what you're also seeing is you're seeing a bunch of different companies, up to about 40 different companies right now, working in these fields. And so they are taking it all the way from the conceptual to the bench scale, to the demonstration. And in some cases, these are going into the license and field deployment phases too. So you've got a wide range of company activities, and you've got a wide range of development statuses for these technologies.
So it's, I want to say, in terms of the commercialization of these technologies, it's kind of new and sort of still entering the market. Go ahead.
Oh, no, go ahead and finish your question.
Yeah, I was going to say, is it a function of the concentration? Is it a function of what the impurities are? Is it a function of the potential volume of lithium that you found? How is there a sense of that we would differentiate between those technologies and their commercial application?
Okay, let's take the first part of that question. And there are a number of companies which are taking this into the commercial sphere. You know, you've got 5 of them working in the southern part of the Smackover right now, and they are looking to develop those resources. So you're talking about Admiral, you're talking about ExxonMobil, you're talking about Standard Lithium, you're talking about other companies that are working there, and others that are working in the Permian Basin, working in other parts of the nation. So there are a lot of companies bringing these technologies to development and to start developing these resources. And those are still in the feasibility stage. Those are still in development phase. Now, your other part of the question is a really good one. You know, I'm talking about how this what the factors are you need to consider. And yes, you're right. You do need to consider your chemistry, because not every technology is going to apply to every resource, you know, because it's all specific on what you've got in the brine to work with. And then also the concentration plays a key role in this, because there's a minimum concentration at which we're looking for economic viability. And we've seen this, we've done some studies related to this, and we've seen minimum concentrations required of 50 to 100 parts per million. But again, it really depends upon your resource, and it really depends upon what technology you're approaching. Then there are also the price considerations and the economic factors to take into account too. So those are some of the things that you would need to keep in mind as far as your development phase here.
Okay, so how do petroleum engineers fit into this lithium story? Like, what's the role of petroleum engineers other than perhaps production of production of oil and gas and produced water?
Right.
Those processes and the surface activities associated with the roles and responsibilities of petroleum engineers. But is there something particular about lithium?
Okay, so let's start with this. You're absolutely right that the petroleum engineering technologies and approaches apply to the production of the brine. Absolutely, because you need to produce the brine, you need to dispose of it, and that gets you into your wellfield technologies, wellfield approaches, as far as drilling and completion, as far as disposal, all of those things. But beyond that, the knowledge base and the techniques used for reservoir characterization and understanding of the oil fields, those translate directly into the lithium space, because you need to understand what your lithium resource is. It's all underground, and petroleum engineers have been doing that for decades, for understanding where the oil is, and this translates directly to where the lithium is. Now, beyond that, you are also looking at the production side of things, because when you get into these technologies, a lot of them is dealing with separation and chemical separation. And so you're talking about cleaning large volumes of water and extracting impurities from them. We do that all the time with the oils, as far as, you know, not only removing the impurities, but also cleaning the water before it goes to disposal. So the petroleum engineering and the process engineering and the mechanical engineering, chemical engineering, all of those fields, which are cornerstones of petroleum engineering approach, you know, those play a key role in the DLE process and in the extraction of lithium in these manners.
Great. Okay, so there's a place for us. And so how do we put this together in terms of maximizing the value proposition for lithium extraction? My first reaction would be that it's part of the stream of activities that you would do under oil and gas operations with the produced water, but maybe there's additional elements to the value proposition.
Okay, that's a great question. And it really depends on how you're approaching this. Because if you're starting off with your point coming from an oil company perspective or a natural gas perspective, where you're producing water, then yes, this is another revenue stream for you. And it would all at that point depend upon what your concentrations are and what your processing and what your technology potentials are. So you could build essentially a side stream for this, and as long as it pays for the processing and the cleaning, then yes, this is a good value proposition for the oil companies. Now, the alternative, if you want to look at it another way, is going after the water itself. So you would go down into the aquifers below the reservoirs and see about producing that. And again, that's the technology question. That's the resource question, and whether the projects become economically viable. And you can look at that and figure out, based off of chemistry, what kind of technologies are appropriate. Then so that's on the producer supply side. On the supply side, the question is, how much lithium can you produce and from where? If you got a technology that you're working with, a particular, say, absorption technology requires these chemical priorities, these chemical properties, where can you actually apply this? And what kind of potential can you get from this? So that's the other aspect of this, either going from here's what you've got with your resource right now to here's what you've got with your technology. And the merging of these two, putting a partnership between them, that's how you're actually going to develop a DLE industry in the United States, merging the resource and the technology and then the project economics. So those are some of the things you want to keep in mind.
Yeah. So, Marshall, if I can speak to the audience, we welcome all your questions from the audience. So, in the meantime, I'm going to keep going here with my questions.
Sure.
So, Marshall, DLE and its potential in the United States. How do we approach that notion? Is this a question about oil price? If you have a high oil price, then you would pursue it in a certain way. The company, is there like a lithium price? I'm not sure how to look at that story from a global perspective. Obviously, we're interested in the United States, and the modeling work is associated with the U.S. endowment.
Right.
Options there, but with respect to worldwide competition, that would be interesting to hear about.
Well, let's start off with the United States then, because first question you ask is, how is this related to the oil price? And it depends, because you're going to want to make sure that if you're coming from the oil field side, you do want to make sure that this is economically viable on its own. So you need to keep in mind or keep a track of the lithium carbonate price, because that is what you'd be producing, and that's what's going into the batteries. Now, as far as what the potential is, like I said, we've identified 2,300 potential candidates for this, and we've done some looking into this, because as far as what the potential production is, and we're seeing that looking at benchmark prices between $12,000 a ton and $28,000 a ton, a very wide range of potential prices, is that we're seeing production on an annual basis ranging from a few tens of thousands of tons of lithium carbonate per year, all the way up over 600,000 tons a year at high prices. And so, the thing to keep in mind for that is that the the forecast demand for lithium is going to be about 230,000 tons in the United States in the next 5 or so years. We're seeing at those levels of price, or at prices in 2018, 24,000. We're seeing production potential which meets that and exceeds that in several cases. And so we're seeing, the potential for lithium exports in the United States. So following what we've done with the oil sector, following what we've done with, the implementation of horizontal well drilling and the fracking and the massive production increases, we're seeing the potential for doing something like that with lithium, where we not only meet our needs, but we're able to exceed them and become a lithium supplier, part of the larger lithium market. So that's the prize. That's the potential, is that you're developing an industry and all of the associated jobs and engineering requirements and industrial base and impacts on the economy. You're developing this industry, and it's got the potential to meet our own demand and to contribute to the world market.
So I don't know a lot about lithium except what you have shared with us, and I'm guessing that others it is kind of new to a lot of people as well from the pure petroleum engineering point of view. Mm-hmm. So before we finish, I'm going to ask you to talk a little bit more just to fill out our background knowledge in the arena of lithium that is outside of the questions that I asked you, but things that people probably should know. But first, I have a question from the audience.
Sure.
And the question is from Energy Stream by MD Jakaria. And the question is 50 to 100 parts per million lithium economically viable for all formation waters, for example, Permian Basin, Bakken, or does it depend on water quality? There's a few more sub-questions, but let's take that one first and see what...
Okay, that's a really great question. And I need to clarify some of that because this is absolutely technology driven. So and depending upon the technology approach you're working for, either absorption, ion exchange, membrane exchange, you're looking at recovery efficiencies that vary, significant. Well, they're all much better than conventional recovery. As a reference point, the evaporation gives you an efficiency of like 40 to 60%. So that's how much lithium recovering. For mining, you're looking at anywhere from 60 to 80% recovery. Now, with the lithium, the DLE technologies, you could be recovering anywhere from 80 to 95 to 99%, according to some of the companies, of the lithium. So your technology is really going to depend or drive what your recovery is. And the technology is dependent upon what the chemistry is and what you're working with in the brine. So, and then also you've got other factors like what volume of water you're working with, what volume, what depth you're working with, what other factors, the availability of getting large enough volume of water. So there are a lot of other factors which are, especially in the Permian or other places of high production, there are a lot of other factors that would determine the economic viability for the projects.
Okay, and then the question goes on, what research supports the claim that 50 to 100 parts per million is economically viable? I'm not sure if that's a general question or if there's a request for references. I'm not sure how to interpret that. Do you have a response?
The response would be that it's going to really depend upon the technology, because at that point you're talking about what the technology recovery is and what you're talking about as far as the setting for the resource. And then also to keep in mind that the companies and there are numerous R&D projects and companies which are exploring this field in order to increase efficiency and reduce costs, which would definitely play a role in your minimum concentration requirements. So that's how I can respond to this at this point, because at that point, beyond that, you need to get down into the specific technologies.
Okay, that's fair. Okay, we have another question from Energy Stream. This is Harry. Is direct lithium extraction taking place when storage salt caverns are being created in the washing process? You know how they just dissolve the salt and
Right. I don't think anybody's doing that at this point because the application would be limited by two things: what the concentrations are and how much lithium you're working at there, in terms of whether it's economically viable, and then also how much water you're working with too. Because it depends on the size of the salt cavern at that point and how much water you're extracting, whether it's going to be viable. The companies at this point are looking at producing the brine itself or working with produced water from the oil and gas fields. So I'm not aware of anybody who's going after associated lithium from salt caverns.
Okay. So we have a couple of questions on the same theme having to do with the innate chemistry of the water, the brine or the produced water, and do those other constituents affect the ability to extract the lithium? Probably with greater efficiency, I guess, is the question. And then one specific element has to do with salinity and pH of the source water.
Right. Now, the salinity and the type of other salts in there is a major area of reference or research. And so the things you need to look at right now are the potassium, the calcium, the magnesium, and the other salts. And this is where there's a lot of work being done in order to selectively extract the lithium from those kinds of salt solutions. So that's going to get you back into the technologies. And specifically answer your question, are there specific compositions which the DLE works with? I mean, this is going to be the technology has to be selected and tailored to the chemistry that you're working with. So that is going to be one of the challenges, is figuring out exactly what you need to work with based upon your local settings.
Okay. And does the DLE process affect or impact the recovery cost of oil?
Well, it could. Now, let me preface this because you're not actually talking about the cost of the oil itself, but what you're talking about is an additional revenue stream, which, depending upon your concentration, depending upon the economics of that, could make certain oil or gas field projects more economically viable. Because if we're a couple of years ago, the lithium carbonate price was up over $60,000 a ton. I mean, we're not expecting that to happen again anytime soon, and we're expecting prices just to be within the $18,000 to $24,000 per ton in the future. But depending upon what the specific economics for that, and yes, it can provide a boost for certain oil projects, and so it could improve your recovery because of the economics. There are associated benefits for that.
Yeah. And I think you already mentioned this briefly, but there's a question about what current oil and gas operators are extracting lithium carbonate from the produced water.
Okay. Well, I'll tell you right now, there are several of them that are playing or working in this field. And the big one, is ExxonMobil. And they are working on a project down in the Smackover, and where they're going after the lithium itself. So that's the big one. But the other companies are looking into this as well. So we're expecting that the other oil companies will either develop technologies or license technologies and develop these resources as well. So that's what we do really believe that there's going to be a significant role for oil and gas companies in this, because they've got access to the resource, they've got access to the technology and to the manpower and the financing in order to pursue these resources.
Yeah. And I think I can squeeze in a real quick question here with a real quick answer. Is it fair to say that anywhere we have hydrothermal wells, like geothermal, that the water associated with those processes also have the potential for extracting, helping us to extract lithium. Real quick.
Okay, real quick. It's a possibility, but it depends on the concentration.
Okay, I guess that's fair. That's fair. You've said that several times. You can only get what you can get in a commercial fashion. Well, this has been absolutely fascinating, Marshall. I think we're at time. I want to thank you so much for joining us today. Thank you, everyone who's part of the live stream today for joining us. I appreciate the questions, and I'm sure Marshall will make himself available to others should you have any additional questions. Marshall would love to talk about this. This is his favorite thing. So thank you, everyone, for joining us today. Marshall, thank you.
Thank you, and thank you, Elena, for doing this. And I do want to thank SPE Live for offering this opportunity to talk about DLE. So thank you very much.
Great. Thank you.
Thanks for listening to the SPE Live podcast. For more content, visit the SPE Energy Stream, the industry's digital pulse, at streaming.spe.org. If you enjoyed today's show, don't forget to subscribe and review. Join us next time on the SPE Live podcast.